The topic today is Docker Swarm and Docker Swarm specifically on DigitalOcean, since the Meetup is about DigitalOcean. A small disclaimer, everything I'm going to show today, I'm going to have 30 minutes, so it's unsecure by default. It's not meant to be in production, and you should put some more effort. The goal here is to explain some basics, how you can get Docker Swarm working, quite the basic stuff you're going to need for development, experiments, and so on, like metrics aggregation and block aggregation, and how you can get Docker Swarm working on DigitalOcean. I saw that many people, okay, I'll follow the slides. About me, I don't consider myself being an infrastructure guy. I consider myself being a full stack developer. I used to do backend, frontend, mobile. At some point, the need came that I had to deploy my own stuff and work.
Speak a little bit closer to the mic.
Okay. Oh.
People can hear you in the back that way.
Yes. So I consider myself being a full stack developer. I started as a backend. At some point, I started doing more frontend, then mobile applications, and then I switched to infrastructure and DevOps. I really wanted to cover the full stack because, in my opinion, this is the direction everything goes. Nowadays, there is no clear separation between mobile or backend or mobile or front-end or DevOps. Everybody should be able to build an application and deploy it. This is the way things should go, in my personal opinion. So a lot of people already use Docker. I saw a lot of hands, so probably the next part won't be that exciting for you, but still we should cover this material. So what is Docker and what is good for? The previous presentation regarding containers explained it pretty well, but since I prepared something on my own as well, I'm gonna present it as fast as possible. For me, the most important thing that Docker containers in general solves is the dependency handling. Or this is exactly the point where you build an application and you give it to the DevOps team to deploy it, and then the question comes back, oh, this doesn't work, which version of Nginx are you using? And then the procedure starts when you start comparing and wondering, and yes, the dependency help. And of course, the evergreen excuse, it works on my local, which is like something that's driving me crazy. The beauty about the containers is that you can use the exact same images across your local system testing and production. And you always want to be sure that you have the exact version of the packages and everything should work, no matter of the Linux distribution, for example. This makes the shipment, deployment, and scaling of services across a variety of platforms very easy. And regardless of that, there's Docker Hub, which contains a lot of awesome images, official and community supported. Of course, community supported images may come with some security risks. So never use something you don't understand that you cannot see the source code now. The first thing that we're gonna do now is we're going to create a Docker engine instance inside of DigitalOcean. How many people already did that? Raise hands. Cool. Okay. That's pretty nice. So to do that, the first thing that you have to do is log in your DigitalOcean account and generate a token. Once you generate this token, the best approach will be to export it as a variable. Once you do that, I already did that, so you don't see my token. So since this may be a live stream, nobody will create 500 instances while I'm creating one, right? All the things that I'm going to show here, I also publish on GitHub. Everything is as simple as possible. I don't use any provisioning systems like Ansible or Puppet or Chef. I'm just using the package which comes with Docker with really simple scripts. So once you understand how this works, you can make the decision which kind of system you're going to use on your own. Because like we already discussed, the most important thing is understanding. The technical solution at the end is not that important. I exported my DigitalOcean token, and the second thing that I'm gonna export, I'm gonna define a variable which contains all the driver required stuff. Docker comes with Docker machine. Docker machine is also not the product that you may use in production. The idea of this project is that you can easily create Docker engines on your local machine, on your Amazon account, DigitalOcean, Microsoft Azure, and try stuff out. So I already exported my DigitalOcean token, so now I'm gonna Yes. Now I'm going to define my driver options. Those driver options I'm going to use till the end of this presentation, and they always going to be consumed by Docker machine. So it's pretty simple. I say that the driver is DigitalOcean, that I would like to create this droplet in the Franklin region. Security reasons, like the access token is a variable, and I would like to use like machines with 1 gig of RAM. I can check really fast in Docker machine if there are some Docker machines defined or they're not. So I can go to the next step and create my first Docker engine. It will take around 2 minutes. Docker machine is logging on the instance. It's using the API from DigitalOcean. It's creating the droplet. Once the droplet is initialized, it's logging inside, it's installing the Docker engine, it's generating the certificates that you're gonna require, and it's setting everything up for you. The good thing is that using different parameters, you can deploy your engine wherever you like. So the next droplets I'm gonna create really fast, but this one will take some time. In the meanwhile, we can investigate what does the concept of build, ship, and run means. So for this demo, I've prepared a really simple Docker image, which is here. Probably I should just make text here. So, probably most of you are already familiar with the Docker file. The image that I'm going to build is pretty simple. It's based on BusyBox. It just copies our hello HTML file inside, and then cat as our interpreter is executing it. Let's imagine that the hello HTML is our source code, and cat is Node.js or Go or whatever you feel comfortable with. So the two tabs are using two different accounts. As you saw here, when I make Docker machine ls, it shows the DigitalOcean instance, and here is my regular account where I have slightly more things defined. The internet is slightly slow. Let's hope for the best. Yes, so here I have more things. Currently, if you make Docker machine ls, you're going to see that my current machine, which I use now for this shell, for this session, is the default one, which is VirtualBox. I'm going to use the docker build command. Oops. Sorry, slightly overexcited. What? Or I can just copy paste. So yes, of course, I'm not in the right folder. have built my image. This is the part with building. The next thing that I'm going to do is I'm going to push it to the Docker repository from a local virtual machine. Good thing that I already pushed that one, so it should say find internet. Cool. We pushed my image from the local system to the Docker registry. And in the meanwhile, the process here to create the instance on DigitalOcean is done. And Docker says that it runs and everything's fine, and I should execute Docker machine environment demo infra. This is gonna load the current configuration for the DigitalOcean Docker engine. I'll do that, and then it says the search variables, then execute those. So if I make Docker info, I'm going to see that currently the provider of this Docker engine is DigitalOcean. If I go back to my own account and make Docker info, I would see that the provider here is the VirtualBox. So we covered build and ship. Now I would like to run this really small image on DigitalOcean. For that one, to prevent typos, there's the guy from the crowd, yeah, they miss an S. I'll deploy my image on DigitalOcean. The Docker engine noticed the image is not there, it downloaded it, and it executed Hello DigitalOcean friends. This is the run part of the concept. So what we have done, we built the image in our local system, we push it to the registry, and we run it in the cloud provider of our choice, which is DigitalOcean. How does this work in the background? In the background, like already pretty better explained, the graphics are definitely better, more technical than mine, from the Rocket guys. I will improve my presentation the next time. How does it work? You have a server, you have a kernel, then you have the Docker engine, and there are your applications. If you want to communicate with this Docker engine, if you're running the Docker client from the same machine, then you're going to use the socket by default. But if you're making remote calls, Docker also exposes the REST API. This is what we did with Docker machine on DigitalOcean. We created a set of certificates. They were automatically copied to our local machine, and now we can communicate with the daemon there. Docker comes with three nice tools. The Docker client, which is the Docker binary that we use all the time. The Docker machine, which is responsible for creating and manage engines. And Docker Compose, which actually doesn't do anything else than communicate with the same REST API, but it has more sophisticated logic. It's checking what's the input and making decision based on that. Basically, it gives you more options to work with templates. So, what is Docker Swarm, and what is good about it? As you may already imagine from the picture, for the Docker we have one well carrying 5 containers. Here we have 3 wells carrying 3 containers. If you ask me, it's a little bit too big team for this job, but this is probably a hard-work decision. The Docker Swarm is the native clustering system of Docker. It turns pool of Docker costs into a single virtual Docker cost. It used the exact same technology. It used the REST calls. The beautiful about it, which we may have multiple discussion what is better, Kubernetes, Rocket, Nomad, Redshift Origin, and so on, but I always have one argument about Docker Swarm, and this is that the API is unified. It doesn't make big difference if you run Docker on your local system or you use Docker Swarm, because the Docker Swarm just extends the regular Docker API. However, the structure looks slightly more complicated. We don't have a single host, but we have multiple ones. We have the kernel, we have the Docker engine. The Docker Swarm relies on two additional components, which are the Swarm agent, which runs on every host, and the Swarm master, which in your best case should run on every host or an instance, or at least couple of them, because the Swarm master agent has high availability out of the box, which means that in case one of the Swarm master dies, the other will see that the leader is gone, and they're going to choose a new leader in case the leader dies in this particular case. And there is also an additional component, which is the key value store, because the Swarm master and agent, they are stateless. They don't know what they have to do. They should have a key value store where they can store data, where the hosts configured, what are the IP addresses, what are the currently running containers, and the key value store is independent. In case the master dies, the new leader should be able to pick up the situation and continue the process where the last leader was. I draw the key value store outside of the cluster on this particular slide. You can also have it inside of the cluster. However, it's quite possible that you have a chicken egg problem. Because the Docker Swarm also stores the data regarding the network overlays there and so on that we're going to discuss later. And then the question is which is first, the master or the key value storage, because it doesn't have state and it cannot boot, and the key value store won't be loaded. There are different approaches that we can solve this problem, but to prevent a more complicated case here, just draw it outside of the cluster. Of course, the key value storage should be also high available, which means that one instance is not enough, otherwise you're going to have a single point of failure, and the whole idea regarding clusters is to prevent having single point of failure. Regardless of that, the Swarm agent mounts the socket of Docker, even if it's not exposed to the outside world, and expose it as a REST call, and Docker machines populate the same certificate sets over all the hosts, so the communication is more or less secure. I say more or less because there's always going to be this guy in the back like, no, it's not secure. SSL has constant issues, which is also the case, but yes. And for the Docker client, Docker and Docker Compose, it does not make any difference if you run a single Docker engine or a Swarm. So we have the single instance. Now we're going to bootstrap a Swarm out of it. For the hanging key value store, I'm just going to deploy this key value store on the instance we just created, where we deploy this really complicated Hello World application. So we use Docker Run, which is really nice. However, yes, regarding the key value storage, I'm just going to start this first and then we can speak about it. So Docker Compose. Everything I'm going to show now is built with Docker Compose. Like I said, no additional tools. Docker Compose is like the next level of the Docker file. You can define all the settings you require to run a container or a set of containers. Their dependencies, network settings, exposed ports. It's like really simple version of, for example, CloudFormation if you work with Amazon, but really easy to understand. So as long as I'm still connected to my instance, hopefully, Docker info, yes, DigitalOcean one. Yeah, okay, mystery solved. compose -d. This means execute the compose file from the current directory and make it in the background. This is -d. So again, the Docker engine noticed I don't have console, so I'm gonna download it and run it. When it goes to the key value storage, you have multiple options. Console is definitely not the best one. I don't say that it's the worst one, but it's just I have experience with console, and I don't want to start another discussion which is better. Other popular solutions are ATCD or Zookeeper. I use console because it has a built-in DNS server, probably the other solutions also have. And the first solution I tried for key value storage for the swarm was console. And I hope I already covered all the edge cases and all possible problems, so I don't feel like switching to another one. Let's try it out. It runs. What's the IP address? Docker machine list. So you're trying to access the console we just deployed in DigitalOcean. I mean, I see the title, it's just connection issue. I hope. So let's hope it's going to evolve in the near future. Otherwise, I should switch to my mobile phone. Okay, let's hope for the best and start provisioning the swarm. So currently, if we go back to the presentation, the stuff we have so far is the key value store. Now we should use console Docker machine to deploy the rest of it. README. Okay. This configuration has slightly more parameters than the regular one. It says that I'm still using the same driver options. It says that this should be a part of the swarm, and this should be also a swarm master. And it also configures the IP address of our key value store, which is basically I execute here inline Docker machine, give me the IP address of the demo infra, which is like the infrastructure node. And the engine options will be the options that are going to be populated in the script, which triggers the execution of the Docker daemon, which is that the cluster store is console, and this is where the cluster can connect. So, let's make it more risky, and since we lost a lot of time, I'm just gonna execute like all of them in parallel. I'm gonna create 3 of them. How is our console working? Yeah. So I can see I have a really basic console installed. It has only one node, and it's completely empty. Yes, because the swarm didn't populate any data in it. So, paste, create the first node.
Multiple master?
Yes. Like I said, it's not needed. Actually, it is in production. You don't want to have a single master, because this means that in case your master dies, your cluster is also gone. The swarm has high availability out of the box. If one of the master dies, another leader will be selected, so you're safe. And yes, I'm executing everything in the same shell because otherwise I should export the DigitalOcean token multiple times. So let's go back to DigitalOcean and see what is happening here. So we have the infrastructure node, we have the node 1, node 2, and 3 are on the way. Zoom in. Yes. So Docker machine takes care of the swarm, creates the certificates, connects them with each other. Oh, you're awesome. Nice. Finally somebody admits it. It populates my SSH keys because I can also use Docker machine to SSH to the instances. Basically, we're gonna create. I don't have a mouse cursor. Okay. Currently, Docker engine, Swarm engine, and Swarm master are installed on all. We have 3 on DigitalOcean currently. On the picture are 4, but that's understandable to save costs. Happy coding, you're awesome, nice. The marketing team is doing a great job. Setting Docker configuration in the remote daemon. Yes, these are those extra engine options we use there. I will use that time to tell you something regarding security. If you deploy Docker Swarm and you want to use it for something that's more or less secure, you should use the private network functionality that DigitalOcean gives you. You may have a second network interface which is accessible only inside of the cloud, and there you should do all your internal configuration. And if you still want to expose some ports, the easiest way is to use either reverse proxy or SSH tunnel. If you go to my GitHub account, you will see that I have a really huge make file which does that, and it generates a list that it makes also the SSH tunnels for DigitalOcean, and you can use it right away. But however, this is more or less work in progress. Okay, so Docker machine list. Oh, it's still copying something. This works faster on my local system. And yes, Houston, we have a problem, of course. Let's see. Let's just be patient. This was something that I could not prepare locally because of the point of having it in the cloud. Come on, be nice to me. Yes. So, now we have our infra node and we have 3 swarm nodes. I would create a 4th one, but maybe then it's gonna fail, so let's stick with the 3 one. Now I would like to use our swarm. So I can still I'm gonna go straight to defining the environment. The difference here is from the like using it as a single Docker engine is that I just have an additional tag which is swarm. And now we make Docker info. And it actually looks pretty familiar to the one here with the single node. But here you have the additional output this is not a single node, but it's actually a cluster. You can see that this cluster has 1, 2, 3 nodes, and the resources we have available here is the sum of that. So This is like a single engine, but it has 3 CPUs and 3 gigs, but actually these are 3 individual instances with 1 CPU, 1 gig of memory. I can run our application again using Docker run. It says hello friends. You don't get the output of downloading the image, because actually when you do that, the swarm is downloading this image 3 times. It's downloading 3 times on every node, because it should be able to reschedule this container in case it dies, which is a new feature in the Docker Swarm. You can configure it to be always respawn or reset always is the exact name of the feature, which means that if you have it running on the first node and it dies, it's gonna be kind of silly if the node 2 should download the image first. So it's taking care of that. So we are currently here. Just to show you what the high availability means, I'm really putting my luck here. That's the risk. So currently I connected to the first node, but I can also connect to the second one, and no matter what I do. I'm still there. If the first node dies, I can connect to the second one, and now the container is going to be rescheduled somewhere on the healthy nodes. This one we covered. So, if you want to start playing with Docker Swarm, you're going to definitely require 2 things. You're going to require some kind of metrics, and you're going to require log aggregation. Otherwise, it's going to be really painful if you have to check the logs all the time on different hosts and see what's the current state. I prepared a really simple way to define metrics aggregation using only Docker Compose. And the next example, we're going to install cAdvisor on every host. We're also going to install Prometheus and Grafana, and those we're going to install inside of the cluster, no matter that they display outside of the cluster currently. Because this is also could be an interesting discussion. If you have a major malfunction and your cluster is gone, you probably still want to see the logs and the metrics. So probably it makes sense not to store them fully on your cluster, but like I said, this is another interesting discussion. So how are we going to make metrics aggregation? We're going to use Docker Compose. Here, I defined in the simplest way possible which components I'm going to require. The first one is the cAdvisor. This is a really nice project from Google, originally built for Kubernetes. As we know, Google has a lot of experience collecting metrics from containers and so on. cAdvisor doesn't support only Docker, it supports also other containers as well. We're going to use Prometheus, which is really nice time series database, really hip currently. And we're also going to deploy Grafana, which Prometheus also can generate charts, but Grafana is way cooler. And one of the main features we're going to use here is the network overlays. As you can see, all which is purple here will be in the same overlay network, a virtual network inside of the Docker Swarm. So the containers are going to see each other, they're going to have DNS records, they're going to be able to resolve each other. And the most important, communicate with each other. How are we going to do that? We're going to use Docker Compose. Docker Compose up -d, going to execute our template. While this is happening, I would like to spend some more time on the template here. Because, like I said, it's going to download everything, all the 3 nodes. A really nice feature introduced in the latest version of Docker is that we can use a built-in DNS server also for service discovery. The way to do it is you can define the network, the overlay network, which is going to be created, and you can also define alias, which means that I can create multiple instances of cAdvisor, and when I use the internal DNS, I'm going to get the IP addresses of all of them, like A records, and it's also going to have really basic round-robin load balancing, which means that if Prometheus tries to resolve cAdvisor, it's going to get all the 3 IP addresses as A records from the DNS server. And this is one of the easiest way to make service discovery or load balancing, which in this case is quite the same. In case one of the cAdvisor dies, the IP address will be removed from the DNS server and Prometheus will stop collecting data. In case I add on the fly another node and create another cAdvisor, it's going to be registered in Prometheus automatically. All of those are default images. The only images which I created on my own is the Prometheus Swarm DNS cAdvisor image, which is, we can take a look here. It's based on the original Prometheus image. I just copied the configuration inside because I didn't want to go into the topic about the storage persistence in Docker Swarm. I just created an image. The only thing which I defined there is that we're going to use DNS service discovery and the cAdvisor cost should be resolved, and all the entries which are coming out of there as an A records from the DNS will be registered in Prometheus, so Prometheus can start putting the data. So in the meanwhile, we have those 3 containers running. An interesting thing which I forgot to mention is that currently I'm connected to the Swarm and I can see that those containers are running on different hosts, but where actually our Swarm agent and Swarm master containers, they're hidden by default. You don't see them, but if you make docker ps -a, they're all there. One Swarm agent and one Swarm master running on every host. But of course, it's going to be kind of tricky if you see them all the time. Something died. Okay, this was our view chip run application. So let's get back to this thing. Of course, cAdvisor got deployed on only one node, and if the internet allows it, since everything is unsecured by default, I can log in the UI and see some metrics there, but they're going to be for a single container, and I cannot really make queries there. So this will take some time to load. In the meanwhile, I use, like I said, since I don't use Ansible or something awesome and only Docker Compose, now I would like to scale the cAdvisor over all the nodes. However, since there are no constraints at all, if I didn't expose any ports from the cAdvisor, which probably would be the right thing to do because you don't want to expose cAdvisor to the outside world. You would probably like to use your overlay network, and I may like scale the cAdvisor 50 times. It's gonna create multiple instances from the cAdvisor all on the same host, or you're gonna have multiple of them, which won't bring us any further. That's why here I'm exposing this port. Oh, here, cAdvisor loaded. So we can see it exports a lot of metrics, Docker containers. Actually, regarding mounting the socket, if you make Docker stats, it's just going to use the same API. This is what the cAdvisor does. And we wait a little bit, we're gonna see what we want. I knew that this is high risk, but live demos is like live cooking. Sometimes it goes wrong. and we still wait. Do we still have internet? Should I connect to my phone? Oh, wow, okay. We have it. These are the metrics that actually the cAdvisor is exposing. First option, we use the Docker client to see the metrics. Not really useful because you cannot see how as the development of that. You just see them on the fly. cAdvisor gonna give you some more detailed view how the situation evolved, but Prometheus gonna really give you more feedback. So I would like to have cAdvisor running on all the hosts. Scale cAdvisor equal 3. This is the message that we spoke about. It says, oh, this container exposed a port, so if I want to scale it 4 times, it won't work because I have only 3 ports available. So now we have one cAdvisor running on every node. And since we use the network aliases and we have the Prometheus configuration to use service discovery through DNS, Prometheus should start collecting data. Okay. Should we hope for a miracle or should I start working on the phone topic?
Maybe you can continue with presentation and get back with it.
Yeah, but the most important part is, let's see, maybe. Yeah, my phone is way faster, okay. And I remember the times where the internet on the phone was luxury. So, we are on the Prometheus. How many of you already use Prometheus? Okay. Time-based database. Time series database. If I go to the target, Prometheus discovered 3 cAdvisors and it already started putting data. It did it through the DNS record. So Prometheus already collects data. We can execute something and we can create some charts. Prometheus has its own queries. I'm just going to show you how it looks in Grafana. So where is Grafana running? Wow, this is so much faster. Yes, guys, like I said, everything's secured. Yes, I'm definitely going to save this password. Yes. I'll add another data source, Prometheus, Prom. Grafana sees Prometheus as Prometheus because this is the host name we defined from the Docker compose. And The whole communication, I'm currently exposing port so we can see what's actually happening, but the whole communication between the containers is happening through the overlay network. Dataset is working. Okay. We would like to import a dashboard. How many of you used Grafana with another background? Backend. I mean, you can also use InfluxDB and some other solutions, Grafit, for example. So, I know where the problem is. Do you want to save and save changes? Save, yes. The mistake I did is that I didn't set that Prometheus is our default and Grafana has some test series going on. So, regardless of the problems with the internet, if this wasn't the case, we could get the call metrics running on the Docker Swarm maybe for 5 minutes, like also with my appropriate jobs. We can already see that data is collected. We didn't configure anything besides of the connection from Prometheus to Grafana. I would like to show you something about, I'm going to log in and start installing packages, and then we can go to the next slide. I know that Grafana is based on Ubuntu, like 500 megabytes or something, but it has one big advantage. This one. I just want to install Dig and show you how the service discovery works in the background. While doing that, we can go back to the presentation and see what we just did was we bootstrap cAdvisor, Prometheus and Grafana with Docker Compose. I used this dirty hack with exposing the port to prevent bootstrapping cAdvisor multiple times on the single physical host. I hope that the guys at Docker Swarm will give us this option in the future to say that one container should be deployed only once. This one we did. Walk segregation. Okay, the walk segregation should work faster. Is there a typo? No. Okay. The walk segregation will introduce one additional layer to our cluster. Similar to cAdvisor, we're going to use another container, walk spout, which also mounts the socket and starts streaming. Not streaming, actually, it's start pushing the walks from the Docker API to Workstash. Yes. We have another Docker Compose file, which is also pretty simple. This is the daemon, which gonna start pushing the logs to Logstash. I use here two community images. The log box is Logstash, and Kibana is Kibana box is Kibana and Elasticsearch in the same image. I use Docker Compose up -d. Let me just see if I'm connected. Yes, of course. Nightmare. Of course, because of the internet connection, the shell is blocked. Car times. So I hope that it's gonna recover, and meanwhile, I'm gonna connect to the swarm from this shell. So Docker info. Yes, I'm there. And I'm in the right folder, Docker Compose up -d. It downloads everything we're gonna require. Okay, in the meanwhile, service discovery topic with DNS. So currently I'm on the Grafana container, and if I like to resolve with the cAdvisor, as you can see, I'm getting out of the box 3 records, 3A records, and they're even in random order every time I send a query. This is a really basic fault balancing, which means that if cAdvisor was a web server and Grafana was an API proxy, the traffic will be rotated. Even if I make like yes, of course, using CDN based, not CDN, but DNS based load balancing has a small disadvantage that sometimes the cache of the client is always taking the same address. So this was regarding the service discovery with DNS, and then everything is downloaded here, and we can go back to the logs aggregation. Similar to the cAdvisor, I would like to scale our logs collecting tool. Over all the containers we have, we get the message. I can do it only 3 times. It's fine. We have only 3 hosts, right? And the next thing that we should do is go to Kibana and see if we can find some logs there. Okay. Discover. Hosts. Yes. So these are all the logs from all the containers, from all the 3 hosts. You can see it here. We can probably also find somewhere here our hello DigitalOcean friends. It will appear in some time. Let's not push our luck. So what have we done? We also deployed block aggregation. Like I said, if this wasn't the case with the internet connection, this would be like 3 more additional minutes. All the sources, like all the stuff that I copy-pasted here, which is highly insecure, you can find on my GitHub account. I would strongly recommend that you use some kind of provisioning tool, like Puppet, Ansible, Makefiles, whatever you think is suits you best. However, be aware that if you don't use Docker machine, you should take care about certificate generation. You should also define the right Docker ranging options and so on, which is making things slightly more complicated. Do you have any questions?
Guys, let's give him a big applause. I have to say it was an amazing talk, and though the internet was really slow, but I think the demonstration gods were with us. So, brave man.
We did something, yes.
Quick question is, you mentioned a couple of times rescheduling, and then you run your image and it exits itself and didn't like try again. So is the key value store holding how many containers should be running, and if it fails, you will try to rerun again, or how does it work?
Actually, my container, this run build ship container died, which was the thing that it has to do because it doesn't have any process. It just showed the output of the text file and then it died, which was the right thing to do. You have a restart policy, which should be set to always, and you should configure that. And you should also go rescheduling, and then in case the process dies, it's going to get rescheduled. I was thinking about showing something regarding rescheduling, but
yeah, okay, I just didn't want if there are some options. Okay, second question, you mentioned that you have Swarm agent running, and if one of them dies, there is like master election, and this is done by Swarm, so there is some consensus protocol, or is like key value store, so console is in charge of that?
Actually, there are two consensus that should be met. Console itself, I mean, console actually doesn't care what's connected, it just stores data. Console, it has its own stuff, and you require a cluster of at least 3. Now we are doing type 1. Console will recover the same way that like the Swarm master will recover. The Swarm master decides that on its own. It's checking inside of console which one are still active, and then it's deciding which one is going to be the leader of that one. These are two completely separated processes.
Yeah, but then if you have 2 swarms, it is like split brain. All of them could like say, I am the master now.
It's going to be kind of hard, no, because it should be approved by at least 2 more.
So the swarm will also be 3 nodes, that is the concept.
Yes,
like
of course.
usual.
Yes.
Okay. Well, and then the DNS is resolved by Docker currently with the new layer, with new overlay connection, like in 1.10.
1.11, I guess. Actually, the DNS functionality is introduced in 1.10. But it wasn't that cool because you can still register the host, but you cannot have the slot balancing. You may not have like multiple containers running in the same domain name, like we did with the C advisor. which was nice. The Docker guys just replaced, before they were generating ATC host files where those IP addresses were hard-coded. Then they switched to DNS in 1.10, I guess, but the functionality wasn't that cool exactly because of the missing multiple entries for a single host name. And since 1.11 they support that, and this could be used for the service discovery. The better probably approach currently, you can also use Console as a DNS server, which has way more functionalities. But like I said, for this current talk, my goal was to do as much as possible with less as possible.
Yeah, I mean, my question was aiming to that if I should use Console or already try to use the Docker itself, right?
For simple things like the service discovery, you can use also like for the C advisor, definitely the Docker one, but Console has way more options.
Yeah.
It's way more complicated, and the health checks that you can define in Console and the conditions there are way more complicated. You can also make third-party health checks, use the REST API from Console, and the health check, which this DNS functionality for Docker is supporting, is I guess if the container is running or not, which is nice. But the real health check, I mean, if you have like team of people and you have to spread them work, you don't stop giving tasks to a guy once he dies. I mean, if he feels tired or sick, probably you should give him a break.
Yeah.
The same thing is about the health check. So the currently built-in health check in Docker and with DNS functionality in Docker, it's not as advanced.
Cool, thanks.
Console is definitely better, but this is what the guys do.
Thanks for your talk, pretty awesome. Just two questions. The first one would be, how do you manage the droplets? Do you need to do anything with them after you set them up once? So,
for this current example, no. In the real life, definitely. Because setting only the Docker engine, it's not enough. If you want to have persistent storage, for example, you should install additional software like GhosterFS or whatever you like to use, which means that you should provision your droplets in more sophisticated way. That's why I said the Docker machine is not enough. From Docker machine, I can upgrade them, I can kill them, I can create them, and some other things. I can SSH inside of them, but I don't have the like really provisioning options. So the functionality which is in Docker machine is pretty limited regarding managing these droplets.
so maybe that's where Ansible comes in.
Yes, if this is your weapon of choice,
Okay.
of course. When you use Ansible, however, you should also use Ansible to create the droplets, install the engine, generate the certificates. It's going to be way more awesome, of course. You're going to have full freedom, but it's going to be another talk.
And you mentioned GlusterFS, so if you want to store any data inside the swarm, you have to set up something like that, and then you can also deploy like a database.
Yes, of course. So this also depends on the database. Do you need a persistent storage for your database, or use some cluster-based database like Cassandra, for example, where as long as this one node is running, your data is safe? Probably you would like to have persistence, yes. If you use bare metal servers or droplets, the options are not that much. Docker supports the swarm also different drivers for network and for storage. GhosterFS is one option. I don't want to offend anybody. I think this GhosterFS project is pretty awesome. I also contributed to the driver for Docker and so on, but it's kind of slow. And I think the activity there is slightly dropping. But I didn't find, I mean, at least for bare metal and on Amazon you have multiple options because you have drivers which suppose the Elastic block storage stuff, and they have so many options. And the Elastic block storage is persistent and you can mount in different images and so on. But probably if you do bare metal or DigitalOcean currently, GhosterFS is your best guess. However, it's slightly slow. I mean, the failover is slightly slow.
Okay, thanks.
Yeah. maybe it changed. I used it for the last time for like 9 months ago.
Are there any other questions? Yeah.
Yeah, thanks from my side for the talk. I have a question about the scaling. You scale the logout for 3 of your Docker machines and also the C advisor. Can you do it only for 2? And also 2 for the C advisor and 2 for the logout, and how does it manage it so that you don't overload one of your machines?
So in this particular case, when it goes to metrics and logs aggregation, probably you would like to connect them from all possible nodes, because this is going to help you prevent problems or solve problems. In more close to the real world example, I would even deploy those 2 services on our infrastructure node, where we have the key value stored, so I can start collecting data out of them. You can scale it, of course, if you have 500 physical instances or virtual machines, you can scale it only on 100, but you can collect the data only from 100. And this kind of services are not that resource demanding because they're not doing much. They're just taking the data from the socket and either making it available to third-party services or sending it somewhere. If we can check here, that's why we have the metrics. So cAdvisor, let's just see everything, like this is the other stuff, and cAdvisor is somewhere here down. So currently the most resources consuming stuff is definitely the Logstash and everything which is Java. So cAdvisor and those 2 are compared to the Swarm, compared to other services, are like nothing, really nothing. If you see the memory, the logbox, it's half a gig, and the tool which is making the logs aggregation is 10 megabytes.
Okay, Angel, thank you very much.